as we talked about this yesterday, this is not fun stuff. Not that you probably don't ever go like, oh my gosh, this is so fun every day in math, or maybe some of you, I don't know. But one thing I will say about this is not easy. So I'm really encouraging you, day 2, practicing more of these. Please don't have your phones out. Please be focusing on this. Go back and watch the video from yesterday, video from today if you need more help. We have one more type of problem that we'll learn tomorrow. Then on Thursday, we'll review, and Friday's another quiz. This is not going to be an easy quiz, okay? Please, 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 ask questions. Try these problems. Don't just copy down what I'm writing. Don't just copy my key. That's not going to help you on an assessment, okay? Okay, so remember, to add or subtract fractions, you need a common denominator. That's the hard part. If you can factor the denominator, you will, okay? You can't factor A, B, or B, okay? There's nothing to do there. So what you start with those problems is just what do they have in common? And we look at every letter, every number, and anything that's in either of these denominators has to be part of our common denominator. So we start with, okay, I know I'm going to create 2 new fractions, and they're going to have the same denominator. What is that denominator going to be? So we start with the alphabet and start with A. We have an A here and no A here. We keep an A. Phones up soon. Okay. And then, so maybe I can sum this up for you a little bit. You always take the bigger number of anything. So we have 1 A and 0 A's. We're keeping 1 A. 1 is more than 0. We have 2 B's and 3 B's. Keep the bigger number, which is B to the 3rd. That is your common denominator. That is what goes under each of those fractions. Yeah. Did I hear Miss Morse? Andy? Were you saying my name? I thought somebody did. Okay. And then what did we do to each of these denominators to get our new one? So old one here, my left finger, and here's my new one. So red is old, purple is blue. What changed from AB squared to AB to the 3rd? One of those B's. We have an extra B. So if we multiply B to the 2nd times B to the 1st, we get B to the 3rd. So that's how we changed our denominator, which is totally fine. We can do anything we want to a denominator as long as we also make that same exact change to our numerator. Okay? And from B to the 3rd in red and AB to the 3rd in purple, what changed? We multiplied by A. Right? To multiply that by A to get that, you have to do the same thing to the numerator. So 11 times A is 11A. Now we'll put it together under one common denominator. So now we can add the numerators because we have a common denominator. And 3B plus 11A can't really be added together. And technically, you could call it 3B plus 11A or 11A plus 3B, either way. Really, we usually put our letters in alphabetical order, but it's not that big of a deal. But that is all you can do for that one. Okay? Okay, we need to add 2 fractions, but they have different denominators. So we know we are going to create 2 new denominators so that they have the same. So we have an x minus 2 and we have an x minus 3. Remember, everything has to be represented. So if it's in one of the denominators, it's going to be in our common denominator. Okay? So we're going to keep both of those. X minus 2, x minus 3. Any order doesn't matter. And now we're going to say, okay, so fraction by fraction, one at a time, what did I do to red to get purple? Well, the x minus 2 was already here, right? I multiplied it by x minus 3 to get this. So if I'm going to multiply my denominator by x minus 3, I have to multiply my numerator by x minus 3. Now be careful. This is the distributive property. It's 101 times x, which is 101x, and 101 times negative 3, which would be negative 303. Do the same thing to your second fraction. To go from red to purple, I already have the x minus 3 here, right? I'm missing the x minus 2. Do the same thing to the numerator. This is a moment you want to be careful. If this had been a minus, we would distribute a negative 19. But it's positive, so it's just 19 times x is 19x. 19 times negative 2 is negative 38. Let me just pause and make sure you guys are with me. That makes sense. Okay. Now that we have a common denominator, we can make it into one fraction with that one common denominator and combine any like terms if we have them in our numerator. And we do. We have 101x plus 19x. 101x plus 19x would be 120x. And then we have negative 303 minus 38, which would be negative 19, 11, 341. Thank you. And that's it. I'm hoping, even though these are fun, even though these are not fun and a little challenging, it's starting to get a little easier for you, a little bit. I'm hoping. Okay. Sorry, that says X. Okay, so as I said, A and B could not be factored in the denominator. So, but if you can factor a denominator, you're going to. And I want you guys to recognize this is the difference of two squares. We have to do that first. So I'm going to cross that out and write below it x plus 9, x minus 9. Remember, your exponent will have a 2. There'll always be a minus in between, and any numbers in the problem are perfect squares. 1 times 1, 2 times 2, 3 times 3, all those. Okay, now let's think about a common denominator. We know we're going to make two new fractions with a common denominator. And I'm going to start with the 7, because it just makes sense to put the number in front of the parentheses. Because it doesn't matter where we start, okay? I'm going to start with the 7. If there's a 7 in this one and not in this one, it doesn't matter. We're keeping a 7, okay? They both have an x minus 9. We're going to keep that. And this one has an x plus 9 and this one doesn't. We're going to keep it. That might be the hardest part of this, is coming up with those denominators. Do we have a question about that one? Do I need to go back over that? There's 1 7 and no 7, we keep a 7. There's 1 x plus 9 and no x plus 9, we kept an x plus 9. There's 1 x minus 9 and 1 x minus 9, we keep 1 x minus 9. Okay? Good? Ish? All right, this fraction, we're missing the 7, right? We need the 7, so we're going to multiply the top by 7. Distributing. And in this fraction, we're missing the x plus 9. Also distributing. 2x times x is 2x squared, and 2x times 9 is 18x. Now we're just going to put it all together. We already know our denominator, right? It'd be 7, x minus 9, x plus 9. And let's put our answer in standard form. Remember, standard form, guys, is your biggest exponent first and then going down from there. So I'm going to start with my 2x to the second power. Then I'll do my x to the first powers, and they are alike. 42 plus 8 would be 60, yes, plus 60x. And then we have minus 7. Look at that. Look, that's crazy looking. And you're doing it. Last example. So I'm just doing lots and lots and lots of problems with you. The more you practice these, the easier it gets. Okay. We have double factoring in this problem. Okay. These are both chart problems. I know that this is going to become 2 parentheses, and I know this one's going to become 2 parentheses. I know there's going to be X in the front of both of them, so I can kind of get rid of some of that little baby steps. This one is what two numbers multiply to get negative 12 and add to get 1. Negative 12 and 1 is what? What is it? I heard someone say it. Negative 3 and 4. Yes, it matters who gets the negative. Make sure you check it. Whatever you have in the chart has to equal what's up at the top. Okay? So it doesn't matter if you put the positive 4 first or the negative 3 first. But I'm going to cross that out. Over here, the two numbers that multiply to get 8 and add to get 6, be 4 and 2. Thank you. Yeah. Hi. Oh, great. Thank you. Yay. All right, so this is the hardest one. We're almost done, and I think I gave you one of these in the homework. We need to figure out what the common denominator is. You're going to use, your denominator is going to be pretty big. You're going to have 3 parentheses in it. Okay, so let's go down the line. It doesn't matter which one you start with, okay? We have 1x plus 4 and 1x plus 4. We will keep 1x plus 4. Okay, so that takes care of that one and that one. We have 1x minus 3 and no x minus 3s. We have to keep 1. We have 1x plus 2 and no x plus 2s. We have to keep that. Remember, if it's in the denominator on the left, it better show up in the denominators on the right. So then we say, all right, what are we missing? In this first fraction, we have the x plus 2, the x minus 3. We're missing the x plus 2, right? So I'm multiplying this denominator by x plus 2. So I'm going to do the same thing to the numerator. Okay, in my second fraction, I have an x plus 4. Yep, I have the x plus 2. Oh, I'm missing the x minus 3. Now, this, on top of this being all this factoring this problem, it's a subtraction problem. Be careful. We're going to now change this to a plus and think of it as a negative when you distribute. So that means this is going to become a plus. And we'll just put whatever the signs are up there. So it's negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. Now we're ready to write our final answer. One denominator. Again, the order that you write these parentheses in does not matter at all, okay? So don't think it's wrong if my answer key has them in a different order. Doesn't matter. And then any like terms in my numerator. Let's start with the x's. 3x plus negative 2x would just be x, right? 1x, 3 minus 2. And 6 plus 6 is 12. Guys, notice I changed that plus there. That I changed it to a plus because of distributing that negative. So don't forget that. That will mess up your numerator if you don't do that. All right, how are we feeling? Are we okay? Is it horrible still? Is it getting easier at least a little bit? A little bit. They're hard, okay? I'm not taking that away from you guys. All right, let's do some homework on the back of the page. Excuse me, back of the page you were on yesterday, page 130. I'm sorry? Seconds plus 712. All right. Number 20. I'm not deserting you, don't worry. So this is D16. Okay. All right, so go ahead and set up like we did on the other ones. We know we're going to create two new fractions. And let's figure out what that denominator is going to be. Because we need a common denominator. Just like I did here. Remember the way we just did it? I would draw. Oh, was it you that asked the question? Oh, okay. I thought it was you. Right, but I thought it was you that asked the question. It was your voice I heard. Okay, all right, I'm not losing it. Okay, so guys, I always start, stay with me, you'll see. I always start with the monomial, okay? Like what I'm saying is, it's not wrong to write, like my common denominator, I'll just tell you, is going to be this in a second. It's not wrong to write a plus 2 with the 2a over here, but it feels weird, right? This one is better than this one. So when I'm looking at my two denominators and deciding what to start with, that's what I start with. If there's a monomial, meaning anything that doesn't have a plus or minus. So I have a 2a in this fraction, no 2a over there. We keep a 2a. Now, by the way, this a and this 2 in this denominator are different 2's and a's. This is a binomial. We have an a plus 2 and no a plus 2. We keep the a plus 2. So our new fractions are going to have that as their denominator. So what we did understand is we went from blue to red. We changed this denominator to be this. What did we do to this denominator to get this is we multiplied it by 2a. Whatever we do to our denominator, we have to do to the numerator. So 2 times 2a is 4a. Same thing with our second fraction. I'm going from 2a to 2a times a plus 2. What's missing from blue to red is the a plus 2. Do the same thing to the top. This is, everyone look, this has got to be so careful right here. We need to distribute a -3. So I'll change this to a positive and put the negative there. That in turn changes this positive. Okay, don't forget to do that. When you change that positive, you have to change that one. And then final answer will be one fraction with that common denominator and combine any like terms. 4a plus -3a is just 1a or a, and then minus 6. When you see a quadratic trinomial, you should know you're going to have to factor that. You have to factor it. That's a chart problem. Whether you make the chart or not is your business. The two numbers that multiply to get 1, add to get 2. Just 1 times 1, 1 plus 1. Okay, so now we're going to make our common denominator. Probably the hardest part right here, deciding what it's going to be. So you go fraction by fraction, and it doesn't matter which one of your two original fractions you start with. And we don't have any monomials here. Everything's got a plus in it, so it doesn't matter which one we do. Okay, so this one we haven't seen one like this. Notice they're all x plus 1s, right? There's two x plus 1s here and one here. So if I use that same the same questions here, I have two x plus 1s and I have one x plus 1. You always keep the bigger number. 2 or 1. 2 is bigger than 1. So 2 of them is what our common denominator is going to be. And so if you compare my left finger to my right finger, red to blue, nothing changed in my denominator, right? This denominator is the same as this denominator. So my numerator doesn't change. The 1 just comes right over. And in our denominator, we only had 1 originally, so now we have 2. If I'm multiplying my denominator by x plus 1, I have to multiply my numerator by x plus 1. This one's got a plus in between, so I don't have to worry about that weird negative stuff. And ready to put it all together. And you could have written that as x plus 1 squared, meaning 2 of them. And standard form, x to the second would go first, then x, and then the 1. All right, I'm going to do one more with you and leave 2 for you guys to do. Oh my gosh, there's 3 of them. What do we do? Stroke. Okay, we're going to do the same exact thing, except with 3 of them. So we're going to have 3 new fractions. Start with numbers. We have 6 and we have 10. What is the first? This is what we started with yesterday. What's the first common multiple? Not factor. 2 goes into them, but what is the first number that they both have a multiple that they share? Like, think about the multiples of 10. 10, 20, 30, 30. No, remember, it's this. Use Evan's test here. Multiples of 6, multiples of 10. So 6, 12, 18, 24, 30, 10, 20, 30. The first one that you come to. Okay? That's good. Okay, sorry. All right, so they're all going to have a 30. Now our letters. 1A, 2 A's, 1A. The biggest number was 2. No B, no B, 2 B's. How many? 2. And now we just figure out what each denominator is missing and multiply the numerator by that. So, 1 by 1, 6A has to become 30A squared B squared. We're missing a lot there, right? We're missing a 5, right? 6 times 5 would be 30. There's 2 A's. We only have 1 here. So far I have 5 times 6 is 30. A times A is A squared. And then I'm also missing B squared. So if I multiply red and purple together, I would get this blue. I have to multiply the top by the same exact thing. 5 times 5 is 25. There's an A. And what do we do with these? There's so much going on in this problem. What do we do with the exponents on the B's? We throw them away, we multiply them, we add them. What do? You add them. B to the first times B to the second is B to the third. Yeah, this one's a little tricky. Not tricky, just a lot going on. All right, 10 times what would give me that? 30. 3. I have 2 A's. There's 2 A's here, so my A's are good, but I'm missing both B's. Right? So if I multiply this purple and red together, I get this blue. That's what you're looking for. Whatever I multiplied my denominator by, I'm going to multiply my numerator by. So 3 times 3 is 9. B to the first times B to the second is B to the third. Okay? And the last one, we're missing 30, right? We don't even have any number there. Times 30. We're missing an A. We need 2 A's. We only had 1, and the B's are good. And we're ready to write our answer, and even though it looks really complicated, there's no like terms in our numerator. Nothing in our numerator has the same exact letters and exponents. So we can put it all under over one denominator, which we have our denominator, and we just put it any order you want. It really doesn't matter. So I'm putting the answers to 27 and 30. I want you guys to try them. What, you didn't rip it out? Oh, well, see you in a minute. Evan, why aren't you working? Come on. You could have gotten a couple of questions done. God, it's writing so slow. Yes. Yeah. Oh, guys, if you have any interest in voting on my pre-calc kids did a project with polar equations, and it might be hard to tell. Like, anyway, in the hallway are the finalists for a contest I have for them, and each of the posters have a sticky note with a number on it. If you want to vote, I'm happy for you to do it. I'd love it if you would do it, actually. You can just take one of these tickets and put your favorite number on it and drop it in the box. So feel free to do that. What? Annie? Yeah. Is it hung? Not all of them got hung. It might not be hung. I don't know. Guys, if you want to vote, you feel free to go do it. Yeah.